Imagine a sprawling enterprise with 5,000 employees. What happens if every single computer, printer, and server is plugged into one giant unified network? The result is a digital traffic jam. Computers rely heavily on broadcast traffic, messages sent to every device on the network, to announce their presence or find a specific address. With 5,000 devices shouting all at once, the network becomes completely overwhelmed just trying to process the noise. Aside from the crushing congestion, there is a serious security risk. Because every device receives every broadcast, the payroll department is sitting on the same open digital floor as the summer interns. There is zero privacy. To fix both the traffic and the security risks, network engineers break it apart. They divide that one massive group into smaller, manageable pieces called segments or local area networks. But dividing the network creates a new problem. If the accounting team in New York is now isolated on their own secure segment, how do they send a file to a server on a completely different segment in London? To bridge that gap, the network needs a dedicated traffic director. This is the router. Routers operate at what network engineers call Layer 3. This means that instead of looking at the physical hardware addresses of devices, they read the logical IP addresses to make their forwarding decisions. Every single interface on a router connects to a completely separate IP network. Without them, our carefully organized network segments are isolated islands. The router is the only way a data packet can cross the water. When a computer needs to send a file to a remote location, it bundles that file into a data packet. Before it transmits anything, the computer runs a quick test. It compares its own subnet mask against the destination IP address to answer one crucial question. Is the target machine sitting here in my local network, or is it somewhere else? Because the destination IP belongs to that London server, the computer realizes the address is remote. It cannot simply hand the packet over directly. Instead, the computer sends the packet straight to its default gateway. The default gateway is simply the local router interface that acts as the exit door for that specific department's network. Individual computers do not have a map of the global internet. They only know their immediate neighbors, so they rely entirely on passing the buck to their local router to figure out the rest of the journey. The router receives the incoming data at its interface and strips away the local hardware formatting. This reveals the true final Layer 3 destination IP address. This routing table is the router's internal map, mapping IP networks to specific hardware ports. For example, if the destination is on a directly plugged-in network, like 192.168.1.0 on the right, the router hands the packet directly to the local switch for immediate delivery. The second outcome, if the destination is on a remote network, the router passes it down the line. Here, router R1 packages the data into a new frame and forwards it to the next router to eventually reach segment 20.2.0.0. The final outcome is rigid. If a packet arrives destined for an IP address, like 192.168.1.34, that does not match an entry in the routing table, the router is entirely unforgiving. It drops the packet in the trash and notifies the sender. The routing table is absolute law. A router cannot guess and it cannot improvise. It will only ever act based on the exact network matches listed in its internal directory. This diagram illustrates a multi-hop journey across an enterprise network. We see a chain of 4 routers, R1 through R4. At every junction, the receiving router checks its routing table to find the next step, handing data off in coordinated hops. Following those tables, our data packet successfully crosses multiple distinct network segments, eventually arriving perfectly intact at the London server. If network engineers didn't use this system, our digital infrastructure would be completely unworkable. We would either have billions of isolated computers that couldn't talk to each other, or one massive, painfully slow, and completely insecure local network. By strategically breaking networks apart and using precise routing tables to bridge them back together, routers act as the hidden logistics infrastructure of the modern world. They make secure, instantaneous global communication a reality.